Hello everyone, this is Jinchang Zhou from ON Semiconductor Power Solution Group. I'm in charge of new product development for TM PIM. My topic is new innovative TM PIM converter inverter brick CIB/CI power integrated module for industrial drives. I'm going to cover the topic, what TM PIM is, the features and process, roadmap, the structural variation, the module topology, pin out and application. I'm also going to cover the released products and its performance in terms of electrical, thermal, mechanical, reliability, and how it compares to mainstream products in the market. Finally, I will talk about the standard and the certification of TM PIM. The name of TM PIMs, or transfer molded PIMs, contains two parts. PIM stands for Power Integrated Module, with norm form in the red box. Transfer molded stands for the process or product adopted, with platforms shown in green box. Different from a normal gel-filled PIM process, TM PIM transfers mold the epoxy molding compound to encapsulate the power devices and the peripheral components in one shot. This process eliminates the plastic housing, glue, and the associated connection and curing procedure. Very concise and robust in manufacturing. It also demonstrating extended long lifetime, offering variation in substrate selection, and flexibility in customized design. It has a small outline, lightweight, and certain corrosion resistance. TM PIM products thus have features of high reliability and high power density, suitable for wide power portfolio products. Since 2019, we have developed and released 6 products for 1200-volt class CIB modules for HVAC and motor drive market. We are now releasing 650-volt class modules and going to release soon the QLP platform. QLP platform module is 80% larger than current released DIP26 module and having pin on 4 sides. It's compact, yet able to deliver higher power. After that, we'll push the power even further as large as 200 amp. Compared to gel-filled power integrated module, TM PIM products has 10 times long temperature cycling lifetime and 3 times longer power cycling lifetime. It has high efficiency. TM PIM products roadmap. In this roadmap, the TM PIM modules are divided into 2 categories by rated power and platforms. DIP26 CIB modules covering the power ranged from 3.7 kW to 10 kW. The product voltage and current rating are listed in the top left table. As it is shown, we have released 1200 volt, 25 amp, 35 amp, and 50 amp CIB and CI modules. We are releasing 650 volt class module with a current rating from 35 amp to 150 amp. This DIP26 offers both standard and enhanced platform, which we will talk about the structural difference in next slide. It has a dual inline package with pins on 2 sides of the module. The final products will offer topology CIB, CI, 6-pack, and PFC. We'll touch the topology in application section. QLP covers power ranging from 10 kW to 20 kW CIB modules. This platform has quad-shaped lead frame and pins are on 4 sides. This will reduce the module size, as well as to satisfy the safety distance requirement at high voltage. It has both 650 volt and 1200 volt class products as well. With first batch release includes 1200 volt 75 amp and 100 amp CIB modules and 650 volt products. QLP is coming soon. TMPIM standard platform and enhanced platform structures. In this slide, we can see the cross-section structure of both platforms. Though they are identical from outside look, pin out, and size, they have different substrate internally. Enhanced TMPIM uses advanced substrate, which is well known for its high reliability. This substrate has thicker copper to further bring down the power module thermal resistance. The standard platform has normal aluminum DBC substrate, except that these two platforms share the same. The power semiconductor devices, which is indicated as chip, is mounted on substrate with solder. The devices between are interconnected through bond wire. The need frame is attached to the substrate to offer outside connection. With all chips, wires, need frame, and substrate are encapsulated by epoxy mold compound. DIP26 CIB, CI power modules share one common pinout. For CI modules, the break pinout will be indicated as NC. This will bring the convenience and flexibility to our customers in case system power to be escalated. The pinout coordination is given in the table bottom left. As can be seen, all power pins that need to make outside wire connections are put in one side of the module. RST to connect the three-phase power grid wire. B and P.12 to connect the brake resistor. UVW to connect the motor wires. This helps the module user in easy system layout. The pinout is also designed in a way that when drive is laid out accordingly, the system connection parasitic would be minimized. On the right-hand side, we put one table for pin-to-pin distance check. The spacing requirement for 1200 volt system is listed in the third column. What distance DIP26 has realized is next column highlighted in green. We meet all the distance target with margin. It's noticeable. When we make measurement, the distance has counted the PCB pad width and also drill hole tolerance. DIP26 CIB, CI power modules share one common pinout. For CI modules, the break pinout will be indicated as NC. This will bring the convenience and flexibility to our customers in case system power to be escalated. The pinout coordination is given in the table bottom left. As can be seen, all power pins that need to make outside wire connections are put in one side of the module. RST to connect the three-phase power grid wire. B and P.12 to connect the brake resistor. UVW to connect the motor wires. This helps the module user in easy system layout. The pinout is also designed in a way that when drive is laid out accordingly, the system connection parasitic would be minimized. On the right-hand side, we put one table for pin-to-pin distance check. The spacing requirement for 1200 volt system is listed in the third column. What distance DIP26 has realized is next column highlighted in green. We meet all the distance target with margin. It's noticeable. When we make measurement, the distance has counted the PCB pad width and also drill hole tolerance. 6 released TMPIM products for HVAC and motor drive are listed. They are 1200 volt 25 amp CIB module, 35 amp CIB and CI module, 50 amp CIB and CI modules. The 35 amp enhanced CIB and 50 amp CIB and CI modules are used in enhanced DIP26 platform. The other 3 are standard DIP26 modules. Interested customer can look up the product information and reference design at www.onsemi.com by typing the product OPN names. From this section, I'll talk about TMPIM performance in terms of electrical, thermal, mechanical, and reliability, and how the performance is comparing with the mainstream products in the market through testing, simulation, and system evaluation under the same working conditions. The example we are using here are 35 amp standard CIB TMPIM and 50 amp enhanced TMPIM. To benchmark with gel-filled module Comp A, which doesn't have base plate, and gel-filled module Comp B, which has base plate. DC data of both 35 amp TMPIM and Comp A are present, with TMPIM in green, Comp A in red. Room temperature in solid line and high temperature in dashed line. There will be voltage drop when there's a certain level of current conducting through IGBT, freewheeling diode, and rectifier. The voltage drop is physically and design defined by the PN junction band gap, resistivity modulation in drift region, and the die size. As can be seen, the 35 amp TMPIM IGBT has slightly higher VC set at a low current and lower at a high current level. The freewheeling diode forward voltage drop is slightly higher than Comp A. This diode is chosen for its low turning off power loss and soft reverse recovery properties. Rectifier has matching and slightly better DC performance than combination A. The AC data and switching waveforms for 1200 volt 35 amp TMPIM are present. The power devices need time to turn on and off by injecting or eliminate the carrier inside. The transient of on and off, representing in waveform, shows short period of both high current and high voltage. It generates power loss at each switch moment. For IGBT, it is shown as E on and E off, representing the energy consumed during turn on and turn off. For diode, it is shown as ERR, representing the energy to turn off the diode and sweeping off the carrier inside. The diode turn-on energy is small and normally negligible from performance comparison. As the data shown, TMPIM 35 amp module has slightly higher turn-on loss at low current and matching turn-on loss when current increasing. The IGBT turn-off loss is smaller. The diode reverse recovery loss also smaller. The overall switching loss is expected better due to no IGBT switching off loss and no diode reverse recovery loss. The 1200 volt 50 amp TMPIM DC data are compared to Comp B part. As the data shown, at high temperature, when devices are working, TMPIM 50 amp IGBT has lower VC set. So is the freewheeling diode and rectifier for the voltage. The 1200 volt 50 amp switching data and waveforms are present and compared to Comp B. As the data shown, the IGBT turn-on loss is higher at low current and lower at high current. the IGBT turn-off loss and the diode reverse recovery loss are both smaller from no current to high current. Based on the DC and AC data, we can simulate the power loss of the module at a given working condition. The DC data will be used to calculate the conducting loss, using voltage drop multiplied by the current. The switching loss occurs at each switching moment. By accumulating the power loss at each moment, we can find the total power loss of the device. At the same given working condition as shown in chart, TMPIM has slightly lower power loss and high efficiency. With known the thermal resistance of the power devices, the temperature rise of the component can be calculated by multiplying power loss and the thermal impedance. TMPIM IGBT has a lower temperature, indicating it has good thermal resistance. A lower device's junction temperature also means it can bear more power if the same temperature rise is allowed. We verified the TMPIM power loss and temperature by designing our power recycling system. In this system, power is circulating the loop with two modules and one isolation transformer. The modules used for comparison are TMPIM 1200V 35A CIB module and Comp A. They both are mounted on identical heatsink side by side. During test, the power is regulated by one module and inverted by another. When the power and current direction is reversed, the module which initially worked at inverter mode now works in rectifier mode. The module which initially worked in rectifier mode now working in inverter mode. As the power factor can be tuned at will, the comparison can cover full working range. Because of the setup, the current through both modules are the same. So is the voltage. This is to ensure the comparison is fair. As the result shown, TMPIM has a lower heatsink temperature, indicating good efficiency and good thermal performance. This is due to the no switching off loss for both IGBT and diode and no thermal resistance. TMPIM modules are evaluated while driving motor, and here are the two examples of the customer feedback. The 35A TMPIM was evaluated at 380V 7kW system. As the motor spin speed increases, the power increases. So is the IGBT temperature. At peak spin speed of 6,500 RPM, the IGBT junction temperature is 110 degrees, which is lower than the maximum allowed junction temperature, and satisfies the customer requirement. The 50A TMPIM was evaluated to deliver motor power as high as 20 kW at high load working condition. It worked continuously with steady-state heatsink temperature and NTC temperature are lower than that with using Comp B part. Both feedback indicate TMPIM has high output power and good thermal resistance. Interested customer can find TMPIM evaluation board reference design at www.onsemi.com. On this board, TMPIM module, the gate driver, current sensor, power terminals, and the PWM singular connector are all integrated. The user can evaluate the TMPIM module performance with minimum effort to make the wire connection. IGBT performance has a trade-off between DC, AC, and ruggedness. While achieving high efficiency, the 50A IGBT, which has highest short-circuit current, was tested at 900V, 150 degree, and passed 10 microsecond short-circuit test, indicating a right trade-off was made for TMPIM power module. Long lifetime. By using epoxy transfer molded process, TMPIM module has gained a long lifetime in temperature cycling compared to gel film module. standard TMPIM power module, gel-filled module comp A, and gel-filled baseplate module comp B are put in the oven side by side 10 pieces each and tested with temperature cycling between -40° and 125°. At 100 cycle, denomination can be observed at comp A and comp B. In gel-filled module comp A, the denomination happened between the copper trace and the ceramic substrate. The location is where the copper trace has big aspect ratio and stress concentrated. At the gel-filled module with baseplate comp B, the denomination happened at the solder layer between baseplate and the DBC substrate, indicating the weakest point. At 500 cycles, the denomination becomes worse. Both comp A and comp B have failed the temperature cycling with the whole length or width has seen the denomination. When denomination getting worse, it indicates the power module heat dissipation capability is worsened. At the same output power, the IGBT, diode, or other power devices can get a higher junction temperature and accelerate the degradation further. At 1000 cycles, the denomination are gross for both comp A and comp B. On the other hand, TMPIM doesn't see any denomination originate from temperature cycling up to 1000 cycles. This is because TMPIM has epoxy to protect the color of the copper trace and eliminate the base plate. Power cycling lifetime. During power cycling, the IGBT was heated up by high current from 20° to 150° or 170° in couple of seconds, then cool down quickly by forced air or liquid cooling. This acceleration test is to mimic the aging effect by power device self-heating. Where temperature changes rapidly, high stress is introduced between material with different coefficient of thermal expansion, and even stress inside homogeneous material with temperature gradient. When temperature change or delta Tj increase, normally more degradation in each cycle and a shorter lifetime span can be expected. TMPIM has been tested at different delta Tj. Withdrawing the lifetime various delta Tj, the lifetime of power module at different working conditions can be extrapolated. TMPIM has seen 3 times better power cycling lifetime compared to gel-filled module. This is due to epoxy protects the bond wire from lift-off and solder from detaching. Attached is the module qualification record for one TMPIM released product. This strict qualification fulfilled both external and internal quality standard and showed clean pass. The items include high temperature, high voltage reverse bias test, high humidity, high temperature, and high voltage bias test, power cycling, temperature cycling, ESD, ALDA. The tests are applied on different devices within the module, checking the electrical drift, any degradation of thermal resistance, and the denomination tomography. Low thermal resistance. Standard TPIM has similar thermal dissipation structure and thermal resistance as comp A. Enhanced TMPIM, which use advanced thick copper substrate, has compared to gel-filled baseplate module comp B. From the table, enhanced TMPIM shows lower thermal resistance in each of the major components. This result partially explains the TMPIM high output power. With delivery similar or high output power, TMPIM has much less volume. Compared to COM-B, the 50 amp enhanced TMPIM module has volume as small as 35,000 mm3. This is 43% of the volume of COM-B, indicating a high power density TMPIM can deliver, suitable to in-cabinet drive, etc. space limiting and weight sensitivity application. Standards and certification. TMPIM module is designed to meet IEC 61800-5-1 requirements. It has 6 mm from the pin to heatsink clearance distance. The CTI material of this module is 600 to fully satisfy the 1200 volt motor drive and HVAC applications. All TMPIM modules are 100% tested in production line to fulfill UL 1557 standard requirement. The UL certification for TMPIM is 46801. TMPIM DIP 26 summary. In the above slides, we have made a lot of comparison between TMPIM and the GFL module. Process-wise, TMPIM module have much less component to assemble. The electrical performance is matching or better in both DC and short circuit performance. TMPIM have good or better thermal resistance. It have good robustness mechanically. It has 10 times temperature cycling lifetime, 3 times power cycling lifetime. TMPIM is designed to satisfy IEC 61800-5-1 standard and UL standard. The test isolation voltage is 3000 volt. Key takeaway: an innovative TMPIM CIB platform have been released. This module, integrated with optimized IGBT freewheeling diode design, is featured with both high efficiency and high robustness, very suitable for motor drive and HVAC applications. It adopts novel design, reliable substrate, and epoxy transfer molded process, has improved the thermal cycling lifetime by 10 times and the power cycling lifetime by 3 times. Compared to normal GFL power module, TMPIM will benefit the inverter system with a longer lifetime and high reliability. The module uses thick copper advanced substrate, eliminate the base plate, reducing the volume by 57% and improving the thermal resistance by 30% than standard module. This has greatly increased the power density. This module is hermetic and encapsulated by epoxy molding compound. The backside metal is nickel-plated. It can prevent dendrite formation between the copper pad trays. It is suitable to work under certain corrosion gas environment. The module, which is designed according to IEC 61800-5-1 standard, has 6 mm pin to heatsink clearance distance. It has been certified according to UL 1557 standard. The file number is 608861. And more TMPIM products are coming soon. Thank you so much for participation and listening to this presentation.